Our journey through the Pythagorean theorem, we have learned that the Pythagorean theorem is used for triangles, specifically right triangles. Nope, not theorem, converse. And the Pythagorean converse, or Pythagorean theorem, is a squared plus b squared equals c squared, where a and b are legs. A is the short leg, b is the medium leg, or you can flip them. Medium then short, doesn't matter for addition. But your c value must always be the longest side, which is the hypotenuse. The Pythagorean converse is when we substitute. We have three values every day, every problem today. You're going to have a short side, a medium side, and a long side. And you're going to substitute those three numbers into the Pythagorean theorem. And we've already done part of this because when we did it, we either said, yes, it works, or no, it doesn't. It was a yes or no. And if it worked, that meant it was a right triangle. And if it didn't work, that meant it wasn't a right triangle. However, today, we're now going to determine those ones that are not right triangles. What kind of triangles are they? Are they even triangles? So, the Pythagorean theorem, a squared plus b squared equals c squared, with that, we can identify the type of triangle it is using the Pythagorean theorem. It's either going to be right, it's going to be obtuse, or acute. So in order to determine, is it a right triangle, is it acute, or is it obtuse, we need to first determine, do the sides even make a triangle? So we have to test it first. We have to look and we have to see, does a plus b, not a squared, not b squared, just regular old a plus b, is it greater than c? A plus b must be greater than c. And here's a picture of what that looks like. I'll ask you this. Can 2, 5, and 7, can that make a triangle? No. Because short side plus medium side is not greater than c. It's even to it. And here's why. It has to be bigger. So let's pretend this is 7, yes? And this side is 2. And this side is 5. And you're like, well, obviously, Mrs. Long, that's not going to make a triangle. That's a ridiculous picture. These 2 points need to touch. Is that true? Yeah, this is an open figure. So what I need to do is, in my mind, I need to squeeze it, right? And I need to go, I need to squeeze it so that those sides meet up. Yes? All right, so I'm going to squeeze it a little bit. This is 7. This is 2. And this is 5. Am I getting closer? All right, I'm going to squeeze it some more. Here's 7. Here's 2. And here's 5. Am I getting closer? Should I squeeze it some more? Here's 2. Here's 5. And this one's 7. I'm getting really close now, right? And I'm going to squeeze it. Here's 7. Here's 2. And here's 5. What's going to happen when they touch? It's going to make a line. It can't make a triangle. If the A side and the B side, if together their sum is the C side, it doesn't make a triangle. It has to be bigger than the hypotenuse. So you have to test. Does A squared or A plus B have a greater sum than C? If the answer is yes, I can continue. If the answer is no, it's not even a triangle. Why bother? If A squared plus B squared equals C squared, we know that's a right triangle. Do you agree? Here's my beautiful picture, right? It's a right triangle. A, B, and C. Yes? So let's talk. What happens, do you think, if A and B stay the same, but C gets longer? If C has to get longer, what do you think is going to happen?
They're going to destroy the right angle.
It's going to destroy the right angle. I like that answer. What else is going to happen? What do you think? Sully, what do you think? It becomes obtuse. So as C grows, right? If C gets bigger, longer, right? It pushes my triangle apart. So if A squared plus B squared, and we still have C squared, but if C squared is bigger, if C is getting greater, right? If your C value is pushing out, if your C value is increasing, that means your angle's increasing. It's pushing your angle further apart. What would happen if your C value, your hypotenuse, shrank? What if my hypotenuse, instead of being this long now, what if my hypotenuse was only this long? What would happen? It would pull it closer, right? So it would become acute. Let's make it a little more acute like that. Right? So that's A squared plus B squared. If your hypotenuse is smaller, decreasing, your hypotenuse shrinks, it pulls that angle in shorter. A squared plus B squared equals C squared is a right triangle. If your hypotenuse value is greater, it pushes it open to obtuse. If your hypotenuse value is smaller, less than, it pulls it in closer and makes it less than 90-degree angles, acute. So let's start practicing. We are going to identify, first off, is it a triangle? Should I continue? And then if it is a triangle, we're going to determine what type of triangle. Are you ready? All right, first one. Ooh, what do I add to see if is it a triangle? What's A plus B? 0.5 plus 1.3? Just in order? Nope. 0.5 plus 1.2, is that number greater than the hypotenuse? So I can continue. So 0.5 squared plus 1.2 squared. And then hypotenuse squared. What kind of triangle is it? A right, because they're equal. So in the right triangle spot, 0.5, 1.2, 1.3. Nailed it. Next one, is this a triangle?
Yes.
7 plus 8, is it greater than 9? Oh yeah, so here we go. 7 squared plus 8 squared. 9 squared. What's bigger? Is the hypotenuse bigger or is the hypotenuse smaller? Hypotenuse is smaller, meaning it is acute. Try the next one. Is it a triangle?
No.
6 plus 8. Nope, that's 68. 6 plus 8. Is it greater than 14? Not a triangle. Do you understand what we're doing? Do you understand how we look for it? Take the rest of these guys, fill them in, talk about it. I will put answers up to self-check.